Good evening, students. Now I'm going to take a class on data transmissions, and previously I discussed about digital and analog signals as well as data. So in computer networks, data transmission is one of the important topic, and we have already know there are two types of signals: analog signals and digital signals are heavily used in computer networks. So signals, as we know, signals is an electrical transmissions of alternating currents on network cabling that is generated by a network component such as a network interface card. An electromagnetic signal is transmitted through air, vacuum, or satellite or antenna to mobile. Signals can be either analog or digital. So first we come to an analog signal. Is a continuous wave form that sends smoothly over time. An analog signal can take on any value in a specified range of values. As the wave moves from value A to B, it passes through and includes an infinite number of values along its path. So a simple example of alternating current AC, which is continuously varied between about plus 110 volts and minus 110 volts in a sine wave fashion 50 times per second. So analog signals such as telephone speeds contain a wealth of details but are not readily accessible to computers unless they are converted to digital form using a device such as an analog to digital converter. So analog signals are usually specified as a continuously varying voltage over time and can be displayed on a device known as oscilloscope. Amplitude is the absolute value of signals at an instance. The maximum voltage displacement of a period repeating analog signals is called amplitude, and the shortest distance between two peaks or cysts of a periodic analog wave is called its wavelength. So now this is the analog signal, and this is wavelength. This is the wavelength, and this is the peak value, and this is the amplitude value. Analog signal can be classified as simple or composite. A simple analog signal is a sine wave, cannot be decomposed into simpler signals, but a composite analog signal is composed of multiple sine waves. Three characteristics, mainly amplitude, frequency, and phase, will describe a sine wave. So if we see here, this is the period and frequency. Period refers to the amount of time in second a signal needs to complete one cycle. So this is the time period, and frequency refers to the number of periods in 1 second. So periods in expressed in hertz, in second, and frequency expressed in hertz. So in this way we can represent the analog signal. Now come to digital signal. This is the digital signals in discrete form. So a digital signal is discrete. It has only limited number of definite discrete values, either 1 or 0. Digital signal transmission of the signal that vary discretely with time between two values of some physical quantity, one value representing the binary numbers and other representing 1. Digital signals use discrete values for transmission of binary informations over a communication medium such as network cable or telecommunication link. So now if we see the two terms bit interval and baud rate are used to describe digital signals. So the bit interval is the time required to send one single bit and bit rate is the number of bit intervals per second. This means that bit rate is number of bits sent in 1 second, usually expressed in bits per second (bps), and baud rate refers to the number of signals units per second that are required to represent those bits. Baud rate is less than or equal to the bit rate. So the baud rate is effective measure of information transmitted and bit rate is measure of data transmitted. Now come to the difference between analog versus digital transmission. So analog transmission means of transmission only analog data. So in analog transmission, data can be analog or digital, but signal is always analog. Remember, propagation can be over guided or unguided media. So analog signal will become weaker in signal strength over distance and will be impaired by noise. An amplifier will boost the energy of the signal but also the noise. So noise is a undesirable random electrical transmission on a computer networks cabling that is generated by networking components such as network interface cards or induced in cabling by proximity to electrical equipments that generate that electromagnetic interference. No coding is possible, and thus if no self error correction is possible in case of analog transmission. Now come to digital transmission. Means of transmitting both digital and analog signals usually assume that signal is carrying digital or digitized data. So digital transmission can propagate to a limited distance before attenuation distorts the signal and compromise the data integrity. A repeater retrieves the digital signal, recovers the digital signal and pattern of ones and zeros and retransmit a new signal. So there are several reasons why we prefer digital transmission over analog transmission. Equipments that used for digital transmission is cheaper as compared to analog transmission. So use of repeater which is recover the data and retransmit are preferred over amplifiers which boost both signal and noise. Errors are not cumulative and so it is possible to transmit over long distance using lower quality guided media with better data integrity. So multiplexing transmission links have high bandwidth and must propagate multiple signals simultaneously to utilize the bandwidth. In digital transmission, we use time division multiplexing. Signal shares the same medium over different time slots. This is easier than analog transmission, where analog signals occupy different frequency spectrum, that is frequency division multiplexing. So encryption of signal is possible for security and privacy. Coding is possible and self-error correction is possible in case of digital transmission. That is why we prefer digital transmission. Now, data rate depends upon three factors in digital communications. So number one, bandwidth available. Number two, levels of signals. Number three, quality of channels. So these three factors affect the transmission rate of the in data communication network. So in this case we discuss the bit rate or capacity of a channel bandwidth, and by applied to theorem Nyquist noiseless channels and other channels for noisy channels. So Nyquist channels, the Nyquist bitrate formula defines the theoretical maximum bitrate. So bitrate is equal to 2 into bandwidth into log 2 to base L, where L is the number of signal levels used to represent data and bitrate is the bitrate bits per second. So by Nyquist theorem, this work is only noiseless channels. But if noise comes, then we apply Shannon's law. So Claude Shannon introduced the formula called Shannon's capacity to determine the theoretical high data rate for noisy channels. So capacity of a channel equal to bandwidth into log2 of 1 plus signal to noise ratio, where bandwidth is the bandwidth of channel, SNR is the signal to noise ratio, and capacity is the capacity of the channel in bits per second. So the signal to noise ratio is statistically response of power of signals to the power of the noise. So in this way we can determine the channel capacity. So now data communication link. So the component of basic communication link between two endpoints or nodes are actually the sender and receiver end. So if we see how data are transmitted, then we are going to discuss some interface also, hardware interface, DTE and DCE. So DTE means data terminal equipments, so and DCE means data communication equipments. So the computer system or communication stations are grouped together, classified data terminal equipments. A computing system part of a DTE that contains software and hardware needed to establish and control the communication link between primary and secondary stations. So an applications program used by DTE use protocols that defines a set of rules that determines the requirement for the successful establishment of data link and the transfer of actual information between the stations. Again, DCE, data communication equipment or data circuit terminating, is a modulator and demodulator modem. This device is used to convert a serial data stream into a form that can be used by the connecting medium communication channel to transfer data over a long distance. So in this way we have this communications. So DTE is sender, so it is PC, and DCE is modem. Similarly, modem and DTE is receiver. So and finally, next we come to data transmission. So how data are transmitted. So data transmission, the successful transmission of data depends particularly on two factors: the quality of signal being transmitted and characteristics of transmission media. So data transfer mode, data communication links are configured to satisfy particular requirement for a given system. So primary section, there are lots of transferring mode of data. So data transfer can be one directional only or bidirectional. The method of sending and receiving data in further divided into three types: simplex, half duplex, and full duplex. So a system or a particular data transmission can be configured to send and receive data in one direction only, is known as simplex transmission. For example, the primary would always transmit data to secondary, and secondary would not be required to respond and sending in return. So simplex, one way, only one directions sending, it is simplex. And bidirectional, then we have two types of data transfer mode. One is half duplex and full duplex. For example, there are two basic methods: bidirectional data transfer, we have already know, half duplex and full duplex. In half duplex allows transmission of data in both directions between primary and secondary stations, but restrict this transfer only one direction at a time. So in case of both directions, then it is full duplex, but at a time if in one direction data sent, next time it say in other direction, then it is half duplex. So the half duplex and full duplex, if we see, this is so half duplex mode, each device can both transmit and receive data but not at the same time. So it is half duplex. And when full duplex mode or duplex, both stations can transmit and receive simultaneously. The full duplex mode is like a two-way street with traffic flowing in both directions at the same time. So in full duplex mode, signal going in either direction and share capacity of the link. this is the way. Now character codes. So there are lots of character codes. ASCII we know, I think we have known there's ASCII code, 7-bit code, American Standard Code for Information Insertions, and it is an Unicode is 16-bit Unicode. Now ASCII character code, we have already known this, hexadecimal and ASCII code. Now EBCDIC, this ASCII big form of extended binary coded decimal instructions code. EBCDIC is an 8-bit binary code representing the same set of characters that original 7-bit ASCII code, but in a different sequence. Now come to digital data transfer rates. So digital information in serial form is transferred at a distinct data rate. It takes time to send information 1 bit at a time from one place to another. Data are sent serially to reduce the number of transmission lines or path to a single pair. Data rate at which digital information is sent or received is called bit rate. So it is serial transmission. So data transmission mode, there are two types of data transmission mode, serial and parallel. Transmission of data across the link can be accomplished in either parallel or serial. Data transfer from one device to another device is always either by parallel transmission mode or serial transmission mode. In parallel mode, multiple bits are sent with its clock tick, and in serial mode, one bit is sent with its clock tick. So this is parallel, and serial is again we divide two modes, asynchronous and synchronous. So parallel transmission, a form of signal transmission that sends information 8 or more bits at a time over a cable. Parallel interface are used mainly to connect printer, hard drive, and other peripheral devices. The mechanism for parallel transmission is a conceptually simple one. So here this is PC to printer, so 8 bits per second transmit at a time. This is parallel transmission. Again, serial transmission, a form of signals transmission that send information 1 bit at a time over a single data channel or data link. So serial interface is generally used to connect data communication equipment DCE such as modem and data terminal equipment DTE. So again, serial data may be two types, synchronous or asynchronous. So synchronous means serial data are data which requires a synchronizing clock signal between sender and receiver, and asynchronous means serial data that does not require a synchronizing clock or signal between sender and receiver. So this is serial transmission. So 1 bit at a time serially transmit from sender to receiver. So synchronous data means synchronous data require a coherent clock signal between transmission and receiver. So data clock to synchronize the interpretations of the data sent, and in case of asynchronous it is need not. So here we see the synchronous and asynchronous transmission. Here you see this is the synchronous frame format. So flag field, control field, data field, and control field and flag field. So this is the frame format of the synchronous frame. Similarly for asynchronous data transmission, the asynchronous data format incorporates use of framing bits to establish the beginning start bit and ending bit of the data character or word. So in asynchronous transmission is simple and cheap but require an overhead of 2 or 3 bits per character. So for example, 8-bit code using 1 bit long stop bit and 2 out of every 10 bits convey no information, but they are merely for synchronizations. So in this way we have now transmission efficiency. So transmission efficiency, we can find data bits sent by total bits into 100. So this is the efficiency of transmission channel transmission. Now transmission impairments. So transmission is the act of propagation through the medium and receiving and processing of signals. So transmission media are not perfect. So the imperfections cause impairments in the signal sent through the medium. This means that the signal at the beginning and end of the medium are not same. So there's mainly three impairments we can see in the transmission impairments in the digital signals. These are attenuations, distortions, and noise. So transmission medium is imperfect, and these impairments should be always try to improve so that communication take place efficiency. Attenuation means loss of energy. So signal strength reduce over time. When signal travels to a medium, it loses some energy so that it can overcome the resistance of the medium. So original signal, amplifier, attenuate again, amplify the signals to get recovered. This is that in the next. So this is some method to find distortion. Distortion means that signal changes its form or shape. The distortion of electrical signals occurs as passed through metallic conductor. Signals that start at the source as clean and rectangular pulse may receive. So this is actually sense of form. Delay distortions. So delay distortion occurs guided media. Now noise refers to unintentional signals voltage introduced in a line by various phenomena such as heat, electromagnetic inductions created by other sources. So noise also create problems. So this is also considered as impairments. So there are different noise: induced noise, white noise, channel impulse noise, interference, crosstalk, etc. Now this will need another class, so today I stop here. Thank you.